Where to start, huh? Well, I hope that everybody had a good chance to stay late and get some coffee because this room is a little bit chilly. My name is Jim Navarro. I'm the sales representative for Latin America from Meteopress. And I want to, on behalf of Meteopress, thank you, the organizers of this event. Let's see. We at Meteopress, we are a radar product company in which we not only provide hardware, but software solutions for all our customers. We are a company that is very hand-to-hand with all the early warning systems and the understanding of all the difficulties that our partners, the weather services, have to go through on a daily basis during their operation systems. Our company offers all kinds of radars that we know from the C-band, S-band, and X-band radars. On the hardware point of view, all our radars uses the latest technology. Okay. The latest technology based on solid-state technology, which is way better, way more efficient, and save all our customers a lot of trouble based on the maintenance part, reducing their cost and make it more obtainable for all of them. From the software point of view, our software uses the latest technology based on artificial intelligence, which helps understanding what's happening with the weather systems, helps and works together hand by hand with all the forecasters in terms of giving them a hand and the tools they need in order to see beyond what the radar is telling them, making free their time a little bit more, understand the physics, and learn a little bit more of what's to happen. Our company has a very broad experience within the world. We have several customers all around the globe that has trusted us with that kind of technology. We all know that our weather systems, especially weather radars, are not a very inexpensive line of work. That's why it's important that all our customers that entrust their products to us, they obtain what they are paying for. And they are guaranteeing that product by having their support to our sales force. One of the latest achievements that we had was within the New Zealand project. New Zealand had a very specific problem, which was in order to forecast, and this is very related to what we heard this morning in the Caribbean, in order to forecast to what or see what's happening to them, they needed a way to see it before. But it didn't happen. New Zealand is a place that is surrounded by water, and having systems beyond that point in the nearby countries is very difficult to have that. However, the few countries that are outside their borders, they don't have the budget for it. So they work in collaboration with a little island called Tonga in order to, by using the finances from the New Zealand government, they could install this radar in the Tonga Islands, benefiting not only the Tonga Islands that they didn't have the way of sending a radar, but also benefiting New Zealand's forecast systems by seeing what was happening, what was going on into their systems. It's a very collaborative project in between two nations, very important for the region. And because, again, the structure, finances, and physical situations, they had some troubles. We were able to provide to them with not only a fully functional radar, but also a solar power radar, which is very innovative in a system that it is able to sustain up to 3 days, at least, depending on the battery systems that we use, if there's no power. Again, remember, on a tiny island, power is the first thing to go. So in this case, our radar, the one that we installed, is able to be totally sustainable from the power point of view. It's battery operated. Everything that when we ship it is contained within a container that is used as a part of the tower and also will warehouse all the battery system. It is so important that the WMO director and the president of the United Nations attended the inauguration of this system because it was a collaborative effort between the two nations. Our radars are so compact, and we're going to see this in the next film, that are being able to be installed in very different situations. We don't need a very very strong tower because everything is self-contained within the radar. One of our best products that we have is a product called Mesh, which is able to estimate the size of hail falling. This is something brand new and it's been proven to be very supportive for specific forecasting situations. In this case, with the current radar systems, we're able to only detect where hail is falling, but we don't know the size of it. We could do some estimations. With our product, that is proven the type of hail and is basically being measured on the ground as it falls, which is very important for systems like aviation and civil protection. Because our radars are very, very light, we could install these kind of radars in any kind of scenarios, like structural towers just by itself, like we all know all of them, or in existing structures that were not designed to support a very heavy radar, but radars that are light. We could even install it on systems on side of the buildings. And why is that? Because we are able to modify the type of radar, the size of the antenna, without compromising the range of that we want to see with the radar. As everybody in the radar technology knows, that one of the best way to prove that the radars are very solid and very trustworthy is giving them to the University of Oklahoma where they could be tested. Well, our radars have been tested by Dr. Dusan Sunik from NOAA, also from the University of Oklahoma, Dr. David Schwarzman. And another important fact is that our radars provide or comes with certifications, the basic certifications that we need in the industry, certifications that proven that the quality of the data that the customer is seeing is actually what they pay for. Also certifications that all the materials used, all the radar is also environmental friendly, as well as one of the main issues that we just saw, for example, in Portugal and in Spain last week, is very secure in terms of information technology. We want the radars to be trustworthy in the sense that the data that is or the system is not hackable, or it will have all the securities that need to be proven by the customers. We work hand by hand with our customers and in providing them that type of radar that they need. We suggest them by looking at the whole scenario of precipitable water during the year from history databases. And based on that information, we developed this map that shows basically what kind of radar is best for the region. Obviously this radar is this image is a very broad image, but it could be customized for every country in particular, telling them which part of the country is best suited for a specific type of radar. For example, on the red sections, we are recommending an S-band radar, but on the blue sections, we are recommending an X-band radars, and so on and so forth. Obviously, this is just a starting point for those customers that don't know or don't have a good idea of what kind of radars they need, which is very important because science is telling them how to start, what is the starting point of that. Again, the main advantage of our radar is compact size. Everything within our radar is contained in this section, in the pedestal section. Nothing has to be transported, or there's no room for equipment down base on the tower. Everything will be on top of the pedestal, on top of a tower, wherever the dish is. Why is this important? Because the transmitter is also contained in here. Therefore, the distance between that transmitter and the focal point of the dish where the signals comes out is very, very short, minimizing the energy needed to power the radar, minimizing the heat generated by the radar. Therefore, the cooling system is minimal, reducing cost, reducing size, and reducing weight of the system. That's why our radars are very, very compact, lighted, and very economical. Again, our radars could be deployed with solar panels, but that doesn't mean that they could not use electricity. They could use the solar panels as a redundant system, or we could use gas if it is necessary as a redundant system. It could be powered by any means that the customer decides. This is just an alternative for situations or locations where there is no power whatsoever. Another important thing in our software is that is implemented with artificial intelligence. Is the only radar that uses that artificial intelligence to see where the blockage part of the radar image is, and it will be trained to see what is happening behind those blockage regions. It could be a tower, it could be a mountain, it could be a building. Therefore, it will help the forecaster see beyond that blockage region, and also will generate some alarms that will help the forecaster see and understanding what will happening with the information. It will be an extra tool for those forecasters in order to help them do early warning systems. We have another product which will help the forecaster, which is separate from the radar product, but we could use that radar image, train it with the local data, and help the forecaster see what the radar image is going to do within the next 12 hours. Radars by themselves are useful for early warning systems. With these products, you will be killing the forecasting part of it, because you will be seeing what you don't see right now with the forecasting models. This will be actual data that you will be seeing what's happening. All that it will be trained by with your data and with your forecasters. And one of the products that we also have that customers ask us most of the time is, what happened in those regions? We don't have the finances to have a steady radar. We need just one radar and take it from one region to another. Or sometimes they have very special conditions in which the forecasting, the weather condition is affecting the country from January to February, January to June, but then another part of the region is affected from July to December. So instead of having two radars, because they don't have the finances for that, they could have a portable solution like ours and take it from one region to another and start swapping it that way. This radar, for example, in this video, is deployed within 1 hour. It takes 1 hour and one button for the truck driver to deploy, and it will be functional in place. It will be transmitting their data, and it will be ready to go. This one could also be powered by solar panels if there is no electricity on site, or if there's electricity, it could be powered by electricity or gas, either way. It's very compact. You don't need a technician to go and install it. Just the same truck driver can install it, and it's very portable. Thank you. And any questions? No? Yes.
Thank you. I would like to ask, how is it possible that the software can predict what's happening behind these blocked regions, like portions of land hidden away from the radar by the mountain? How is that possible?
Yeah, that's a very good question. The software that we have developed is an artificial intelligence model that will see what's happening when the radar is sweeping that region before and after the blockage, but also will be profiling what's happening above the blockage. Okay. And by training with local data and by local expertise with the forecasters, we could tell what's happening to that region based on previous conditions.
Usually to validate and calibrate the radars, automatic weather stations are installed in the vicinity of the radar. Do you do the same? Do you calibrate using data from automatic weather stations?
Excellent. Yes. The answer is yes, when the local weather service, which most of the time is the customer, provide us with that data. We could also use our own rain gauges. However, that's if the National Weather Service or the local weather service doesn't allow to use their data because of security, because of which is most of the time what's happening, we are forced to use our data. But however, what that proves is that we don't have a long history of that data. So we could do with a little training of the proving ground data, but we prefer to use historic data in that case. Again, it's all depending on the facility of the data that we get from the customer. It could be whatever you decide. If you want solar panels to be backup, or batteries in this case, we will use that as a backup, and being the primary, just regular electricity. But if you said, well, we want a gas or diesel generator to be as a backup and still have electricity as your main power source, we could use that. The fact that we use solar panels is just in case in those scenarios, like desertic areas, we don't have any infrastructure, we don't have electricity on site. We could use, again, diesel as a primary source, and then the solar panels as a backup, or solar panels as a primary source, and then diesel as a backup. My time is up, but I'll be on one of the booths. If you have any questions, please reach me out.
Thank you.
Thank you.